Arithmetic Review, Integers, Part 1. The following series of videos will familiarize you with the mathematical skills and concepts that are important to know for the purpose of solving problems on the quantitative reasoning section of the GRE Revised General Test. The revised GRE Quantitative Reasoning sections are designed to measure your problem-solving ability and focuses on basic concepts from arithmetic, algebra, geometry, and data analysis. These videos will include many definitions, properties, and examples. Keep in mind that this review is not intended to be all-inclusive. There may be some concepts on the test that are not explicitly presented in these videos. Nevertheless, you still need to acquaint yourself with the basic vocabulary and properties of numbers. Initially, the math concepts presented might be very simple, but that doesn't mean that they are not important. With that said, let's start with arithmetic and talk about integers. We first need to remember the basics of number lines. Back in Algebra 1, and perhaps even before that, you learned that a number line is formed when a numerical value is assigned to each point on a line. For example, the following line represents a number line, and point A is located at -1. Likewise, point B is located at +1. Notice that number lines are useful to describe the location of a point relative to the origin, which is usually assigned a value of 0. Also notice that this line is broken into two regions, or halves. The half on the right contains positive numbers, and the half on the left contains negative numbers. In general, integers are whole numbers, such as 1, 2, 3, 4, 5, and so on, together with the negative integers such as -1, -2, -3, -4, -5, and so on, along with 0, form the set of integers and are represented by using set notation as follows. We enclose the numbers using curly brackets, like this. Recall that the ellipses mean that the numbers keep going forever and ever, with the implied pattern. In other words, the numbers keep going in both directions, infinitely to the left and infinitely to the right. Also notice that the set of integers are listed consecutively, meaning that the integers are listed in order of increasing value, without any integers missing in between them. It turns out that positive integers are greater than 0, and get bigger as you move away from 0. For example, 2 is greater than 1. Likewise, the negative integers are less than 0, and they get smaller as they move away from 0. For example, -2 is less than -1, and the number 0 is neither positive or negative. But remember, it is still considered an integer, but does not have a particular sign. It is considered sign neutral, but an integer nonetheless. Any numbers between integers, like 1/2, 1/3, and -1/4 are not considered integers. They are called fractions. Remember, the set of integers do not contain fractional parts of a number. Moreover, fractions and decimals cannot be listed consecutively, like integers can. Fractions will be discussed in a later video. Now that we know what integers are, let's discuss the different types of operations that can be used with integers. The 4 basic operations that can be applied to integers are addition, subtraction, multiplication, and division. Before we talk about these operators, let's talk about the absolute value of a number. The absolute value of a number is equal to its distance away from 0 on the number line, which means that the absolute value of any number is always positive, whether the number itself is positive or negative. The symbol for absolute value is a set of double lines. In essence, the positive number of any pair of opposite non-zero numbers is called the absolute value of each number in the pair. For example, 1 and -1 form opposite pairs. One is a positive integer and the other a negative integer. The absolute value of +1 is equal to 1, and the absolute value of -1 is equal to 1. In general, if a is a positive integer, then the absolute value of a will be equal to a. If a is a negative integer, then the absolute value of a will be equal to -a. And if a is 0, then the absolute value of 0 is equal to 0. Alright, let's move along and talk about addition and subtraction of integers. If we have two integers, say a and b, then we can add them in 5 distinct ways. If a and b are both positive, then we add their absolute values and prefix the positive sign. For example, 3 plus 7 equals 10. If a and b are both negative, then we also add their absolute values and prefix the negative sign. For example, -6 plus -2 equals the sum of their absolute values, 6 plus 2, which is equal to 8, and then we prefix the negative sign. If a is positive and b is negative, and a has a greater absolute value than b, subtract b from a and prefix a positive sign to the result. For example, 8 plus -5 will be equal to 8 minus 5, which is equal to 3. If A is positive and B is negative, and B has a greater absolute value, then subtract A from B and prefix a negative sign to the result. For example, 4 plus negative 9 is equal to 9 minus 4, which is equal to 5, and then we prefix the negative sign. If A and B are opposites, then their sum is equal to 0. For example, 2 plus negative 2 is equal to 0. Okay, in a nutshell, when adding or subtracting integers, if the integers have the same sign, add their absolute values and prefix their common sign. If the numbers have opposite signs, subtract the lesser absolute value from the greater and prefix the sign of the integer having the greater absolute value. Alright, in our next video we will focus on the concepts and terminology that are associated with the third basic operator, known as multiplication.